Okay, so question 11 of 3.3 is use the four-step process to find the slope of the tangent line to the graph of the given function. The given function was f at x equals root x minus 5. Um, for step 1 of the four-step process, we would use the equation f at x plus h, and we sub in x plus h into all of the x variables, where there's only one in f at x equals root x minus root x minus 5. So we sub in the x plus h into the x, which would give us root x plus h minus 5. That's step 1 of our four-step process. And next we would do step 2. Is the equation given was f at x plus h minus f at x. So basically we'd use the step 1 answer, which is root x plus h minus 5, and sub it into step 2, which would give us root x plus h minus 5. And then for the minus f at x, we would just sub in our f at x, which is our given, root x minus 5, and sub it into the equation, which is minus root x minus 5, and that would give us our step 2. So this gives us the equation f at x plus h minus f at x, where in step 3 of our four-step process, f at x plus h minus f at x. So basically just sub in the answer for step 2 into the top equation of step 3, so that all over h, which would give us root x plus h minus 5 minus root x minus 5, which is just the step 2 answer. We're just changing it by putting it all over h. And then for part 2 of our step 3, we would what we want to do is get rid of each root symbol. So the root symbol all over this variable and over this one. So just what we do in this case is multiply this equation, this variable by root x plus h minus 5 plus root x minus 5, and we multiply both the top and the bottom over root x plus h minus 5 plus root x minus 5. This will give us our fourth part, which is just the top of this equation with no root symbol, because what we're doing is just multiplying each of them by each other, not to get rid of the root symbol. Okay, so for the third part of our third process, what we did was we took the root symbols off the top of the variable away by multiplying it by the top of the second variable. So that would give us bracket x plus h minus 5, bracket minus x minus 5, bracket, all over h, bracket square root x plus h minus 5 plus root x minus 5. How we got this bottom variable was by multiplying the bottom variable of this part of the equation into h, which gave us I just stated it, h root x plus h minus 5 plus root x minus 5. And how we got, moving on to the next part was, we got the equation h over h root x plus h minus 5 plus root x minus 5. How we got h was we just, in the third part of the process, we expanded the negative symbol into x minus 5, which gave us, x plus h minus 5, and then expanding the negative symbol into this equation would give us negative x minus 5. That would leave us just by canceling out the x's, canceling out the 5s, just leave us with h on top. That's all over root h bracket x plus And that left us with the h over h bracket root x plus h minus 5 plus root x minus 5, which then leaves us with the last part of the third step process, which is 1 over root x plus h minus 5 plus root x minus 5. How we got this was we just canceled out both h's, and that left us with a 1 on top. Sorry, a 1 on top. And that's the last part of the third step process. Okay, so for the step 4 of the 4-step process, you would take the equation of step 3, which is 1 over root x plus h minus 5 plus root x minus 5, and you sub it into the equation f at x to the limit of h approaching 0. So what you do is you write down the equation 1 over root x plus h minus 5 root plus root x minus 5, which would leave us with, oh sorry, you sub in the h, all the h's in the equation, which there's only one, for 0. So that would equal 1 over root x plus 0 minus 5 plus root x minus 5, which would just leave us with 1 over root x plus 5 plus root x plus 5. And what we do is we just add the root x plus 5 plus root x plus 5, which would equal 1 over 2 root x plus 5. And that would be our slope for a tangent line. Okay, so therefore, the slope of our tangent line, is
You spelled tangent wrong.
tangent.
Okay, I think so. Three,
Oh wait,
three.
let me write the whole thing.
Yo, Hisham, did your uncle also have another kid?
Yeah, Omar,
Is this him?
the baby woman
He's
is.
so cute.
Like you, psych, ugly bitch.
Fuck you, bitch.
Like,
Is this him?
yeah.
1 minute. Okay, I just want to do this.
Okay, 3, 2.
Okay, so for question 10, it wants us to use the 4-step process to find the slope of the tangent line to the graph of the given function. The given function in this case is f at x equals 2x squared plus 5x. So for step 1, we use f at x plus h, and for all the f variables, we plug in x plus h. So for this equation, it would be 2x plus h squared plus 5x plus h, because there's an x here in front behind the 5, and an x squared behind the 2, and which would give us 2 bracket x plus h and bracket x plus h. Because it was x plus h squared, we expand it to x plus h plus x plus h, which would then give us plus 5x plus 5h. Next, we would have 2, and what we do is FOIL the x plus h into the other x plus h, which would give us x squared plus xh plus xh plus h squared plus 5x plus h. We would only do the inside the brackets. And then next part would be 2, and we're only messing with inside the brackets right now. What we do is we find the common variables, which is x plus h, and add them together, which will give us x squared plus 2xh squared plus h squared plus 5x plus 5h, which will give us the ending equation of 2x plus 4xh plus 2h squared plus 5x plus 5h. How we did that was we just expanded the 2 into each variable. So, sorry, this is 2x squared, and yeah, basically multiply them all by 2. Step 2 is give us the equation f x plus h bracket x plus h minus f at x, which would then give us the equation of 2x squared plus 4x squared plus 2h squared plus 5x plus h. That is basically just step one, the step one equation of our four-step process, minus f at x, which is just our given function, which is f at x equals 2x squared plus 5x. Put it into the f at x plus h minus f at x equation, and what we do for the part 2 is we just take out the brackets, and it would equal 2x squared plus 4x squared plus 2h squared plus 5x plus 5x minus 2x squared minus 5x. How we got that was we just expanded the multiplied the negative symbol by everything inside the bracket, which gave us negative 2x squared and negative 5x. Part 3 was just collecting the like terms, which in this case was just the 2x squared and the 5x. So it gave us 2x squared minus 2x squared plus 5x minus 5x, and which leaves us just with 4x squared plus 2h squared plus 5h plus 5h. That left us with that, just 4x squared plus 2h squared plus 5h. And what we have here is we have an h we can take out of each variable because they're all common, and we just took out the h, which left us with 4xh plus 2h plus 5. And for the third step of our equation, or of our process, it gives us the equation f at x plus h minus f at x all over h. We have an h already at the beginning of this equation, because that's the ending of step 2. That was just basically f at x plus h minus f at x is just this equation right here, just as we did for step 1 and step 2. Gave us h, 4xh plus 2h plus 5 all over h. So what we can do here, because we have an h at the bottom and an h at the top, we can cross both them out, which will just leave us with 4xh plus 2h plus 5. And we bring the four-step process. What we do is we just bring, the f derivative of x, which would equal the limit of h that approaches 0. We would bring the equation they gave us in step 3, which is 4xh plus 2h plus 5, and we'd sub the 0 into every h in the equation, which is just the h after the 4xh and then the 2h. So that would just give us 4x times 0 plus 2 times 0 plus 5, and anything times 0 is 0, which would just leave us with 5. So therefore, the slope of the tangent line is 5.